Hi, my name is Matthew, and welcome to a three-part video series on cybersecurity topics. Today, we'll be talking about SQL injections. So first off, what is SQL? SQL stands for Structured Query Language. It is used to communicate with databases, and it allows you to store, manipulate, and query data. The data inside an SQL database is stored as a number of tables. Here we have a student table with the ID, name, and degree of a student. In SQL, we identify a table using its name. Each table has a series of columns, and each table also is populated by a number of rows, also known as tuples. Using SQL, we are able to add new tuples, remove them, or search through them using the content inside them. The syntax of SQL is similar to plain English. For an SQL query, it is divided into three main clauses. We have the select clause, which specifies the columns we want to select. We have the from clause, which specifies the table we are selecting from. And we have the where clause, which specifies the filters that we are using for our search. Here is what the student table looks like. We have the ID, name, and the degree of all the students. Using an SQL query, we are only trying to select the ID and name of the students which are currently studying a Bachelor of Computer Science. Looking at this table, this means that we should only be selecting Alan Iverson and Avon Barksdale, which is what is output. Now, SQL injections take advantage of the quotation mark which is used to form the where clause query. Using SQL injections, an attacker can perform malicious SQL statements. Here, we shall now head to a live demo. Now, based off the previous slides, we were trying to select the ID and the name of a student from the students table if they were studying a Bachelor of Computer Science. This here is a perfectly valid SQL query. But what happens if the degree string has a quotation mark in it? As you can see from the syntax highlighting, we have resulted in the early termination of the SQL query. If the attacker wants to append their own SQL statements, they could. For example, they could decide to drop the entire students table. And to make sure this is a valid SQL string, they can simply comment out the rest of it. Here we now have two separate SQL statements. One to query for the students based off the degree, and another which drops the entire students table. As you can see, just due to a mismatch in quotation marks, an attacker can perform serious damage to your system. So now we will attempt to perform an SQL injection for an application I designed. So what I designed was a UNSW course finder. It is able to search through the courses in a UNSW database. If I don't search for any particular substring, it will display all the courses at UNSW. So as you can see, we have the course code over here, the units of credit, and the terms that is offered. It also displays the number of UNSW courses which are found. In this case, 3,479. So what my search bar does is look for the existence of my search string in the course code. So for a computing course, I type in comp. And this here will display all the computing courses. If I wanted to search using the 4-digit suffix, I can also do that. And here I found that there are two courses with the 4-digit suffix 1521. We have an anatomy course, often in term 2, and a computing course, often in terms 2 and 3. So based off the structure of the website, we can kind of infer what the SQL statement behind it looks like. We are trying to select three unknown columns from some unknown table, and we are trying to match some column value and look for the existence of 1521 as a substring. So in order to check if we can perform it in SQL injection, what we can do is put a quotation mark in our string. And as you can see here, we now have an uncompleted statement. If we will put this in our website, and I just put a quotation mark, if our website crashes, this could indicate that we can attack the website using a SQL injection. And as you can see, there is a server error. So here, I know that I can perform an SQL injection. So if I go back, and I just comment out the rest of the code, this here should be a valid statement. And as you can see, this statement actually worked. So in order to perform an SQL injection, I need to know what database am I attacking. And I can do this if I know that there's a function which exists in one database language, but not the other. So first things first, I'm going to test for the Postgres database. So I'm going to call the pg_sleep function, which only exists in Postgres, and see if this works. So what this would do is it will cause a 1 second delay to occur between each result. So first things first, I'm going to first reset this, so I can see if there is a difference. Now there should be a 2 second delay when I click submit. 1, 2. As you can see, there was a 2 second delay, so now I know I am using Postgres. Now I can perform more specific attacks. So now I need to know what kind of attack am I performing. This is a UNSW database, so I might be interested in getting the ID and the password of every UNSW staff and student member. So to do that, we'll be using the union operator. So what the union operator does is we'll basically get a table and append it to another table. So I'll copy my previous results, and what I'm going to do is add a union and try to select A, B, and C. And we should see that these 3 values are appended to our table. So if I copy that into my search bar, I can now see A, B, and C are appended to this table. So now I know I can perform more complex injections. So now that I know that I'm using Postgres, I can figure out the table names and columns from the metadata. So if I look up the Postgres information schema, I can figure out the columns from this attribute as well as the table names from this one. So here we have a value for a table name and one for a table schema. And this is probably what we're interested in. So if I grab my previous query, and now I form a union that selects our table name and table schema, as well as some additional string from information schema.tables. And this here will show me 4 tables. However, we are only interested in the public schema. So if I copy this, this should tell me the list of tables I can find. Alright, so this is the list of tables that I can find, apart from this additional information here from our previous query. So the one I'm probably interested in is people, because that will probably contain information about the people enrolled or currently working at UNSW. So again, what we would do is look through the information schema for columns. And what are we interested in? So we're probably interested in the column name, given that we know the table name. Okay, so now I can form my new SQL query. So I'll grab the previous one, and I need to find out the column name for people table. Alright, so let's do this. I'm going to form a union, select column underscore name with 2 additional strings from information schema.columns, where the table name is equal to people. So if I copy this, I should find out the column names for this particular table. Alright, so now I know that we have a column with ID, some sort name, the name of the person, as well as the password, as well as their ZID. So I'm probably interested in their ZID, their name, and the password. So now we actually know the table name, which is people, and we know the columns that exist. Now I can actually grab the data that I'm interested in. Let's try to grab the ZID, password, and the name of a person. Now query for private data. I'll grab this previous one, and let's try to get something. Union select ZID, name, and password from people. And what do you know? We now have private information which we should not have access to. I now know the ZID of Craig Smith is this, and we now know his password. And this could have been credit card information, credit card data, or your password to some login. So as you can see, this is how you perform an SQL injection, and this is what we can do. So to prevent SQL injections, we have to make sure that anything within a string can't terminate the string. So here, we have to make proper use of escape characters, such that this whole thing is interpreted as a string and not this part here. If you want to see my implementation of how I created the system, as well as how to fix it in order to make sure SQL injections can't occur, stay tuned for part 2 of this video.